All right. This is an honors only podcast. So if you're in one of my standard classes, you don't have to watch it. You can watch it if you want. That's fine. But I only require that the honors sections have to know this material. And this is going over some special types of chemical reactions and mainly looking at special decomposition and special synthesis reactions. So I will have questions where I ask you to predict some more of these complex reactions, but really if you just remember these special types, you should be able to predict products no problem. Okay, so just a reminder, synthesis is when you take two or more substances and you make a compound, you make one product. So these are our special synthesis reactions. So you might want to go ahead and pause the video, write this down, and then listen to me afterwards. The first one is a metal plus oxygen will produce a metal oxide. So if I have magnesium and I burn it in oxygen gas, I can get magnesium oxide. Really, this is similar to when I showed you a synthesis reaction and you have a metal plus a nonmetal, because a metal oxide is an ionic compound. So let's say that I take calcium and I burn it in oxygen gas. I'm going to get calcium oxide, and I would have to look at the charges. Same thing as sodium. So sodium reacts with oxygen without burning it. It just reacts with it. It's very active metal. So sodium plus O2 would give me sodium oxide, a metal oxide, so sodium oxide. And then I would just look at the charges. Oxygen is -2, sodium is +1, so that would just be Na2O. Okay, so that's an example of that one. That's another example. The second one is when you have a nonmetal plus the oxygen, you'll get a nonmetallic oxide. I really won't ask you to predict products with things like this too often because some of these reactions aren't as predictable. Okay, the third type is a metal oxide plus water will give you a metallic hydroxide. So if I put magnesium oxide into water, I'm going to get magnesium hydroxide. And again, I would have to check the charges here. So for one, you would have to check charges. Ooh, it says check. Okay, so you have to check the charges for number one. You also have to check the charges here. I'll put CC, check charges. So if I had calcium oxide plus water, I would get calcium hydroxide. Okay. A nonmetal oxide plus water will give me an acid. So if I take carbon dioxide and I put it into water, I get carbonic acid. So if I took SO2 and placed it in water, I would get H2SO3. So basically you're taking that oxygen and then you're adding it right here. And of course you would check the charges too. So H has a +1 charge, carbonate has a -2 charge, so that's why it's H2CO3. So again, for 4, check charges. And then you're going to add the oxygen from the water to whatever this non-metal oxide is. The fifth one is where you take a metal oxide and you add it to a non-metal oxide. That's going to give you an ionic compound. So again, you need to check charges here. Okay, so K2O plus SO3 is going to give me potassium sulfate. So again, I take the oxygen and it pretty much just goes over here. And then it creates some sort of ion. So in this case, it would be SO4, which is sulfate. And you would check the charges there. Okay, these two reactions, just remember them. Nitrogen gas plus hydrogen gas will give me ammonia. NH3 is ammonia. And then if I take ammonia and I add it into water, I'm going to get ammonium hydroxide. So don't confuse these two. Ammonium is NH4 plus. NH3 is ammonia. So that's that's ammonia. That's ammonium with a um at the end. That's also called ammonia water, actually, NH4OH. It's a common name. All right, so special decomp reactions. So this is the opposite of synthesis. Instead of having one product, we take one reactant and we break it down into its simpler substances. So H2O, I just break it down into its elements, hydrogen and oxygen. So here's our special decomp reactions. So again, you might want to pause it, write it down, and listen to me. All right, special decomp. So the first one is where I take a metallic carbonate and I heat it up. That'll form a metallic oxide and carbon dioxide gas. So calcium carbonate, when I heat it up, it'll make calcium oxide and carbon dioxide gas. This does not occur with groups or with group 1A. So if I had sodium carbonate, this reaction would not happen like this. It would not release carbon dioxide and sodium oxide. It would be something a little bit different. Okay, so number 2, most metallic hydroxides, when you heat them up, they'll decompose into a metallic oxide and water. So from the special synthesis reactions, we had the opposite. So if you take a metallic oxide and water, you're going to get a metallic hydroxide. So it's the same thing here. So this is just in reverse of the other one. So if I had magnesium hydroxide and I decomposed it, I would make magnesium oxide, and you would check charges here, and water. All right, if I take a metallic chlorate and I heat that up, it'll decompose into a metallic chloride and oxygen gas. So right here we have potassium chlorate, and it decomposes into oxygen gas and potassium chloride. And you want to check your charges when you do that. Metallic chloride. Okay, so right here you would check charges. And you would with here too. Anytime that you have an ionic compound, check your charges when you make it. So another example would be magnesium chlorate would decompose into magnesium chloride and oxygen gas, and magnesium chloride would actually be MgCl2. So this depends on your charges. Any ionic compound will depend on your charges. Okay, the fourth one is where you take a metal sulfate and you heat it. You're going to produce a metal oxide and sulfur trioxide. So aluminum sulfate, when it decomposes, you're going to make sulfur trioxide and then aluminum oxide. And you notice here you have to check your charges. Aluminum is a +3, oxygen is -2, so that's how we get this formula right here. Okay. Most nitrates will decompose into nitrogen dioxide, oxygen, and a metal oxide. So if you were to see something like this, lead nitrate, and it's decomposing, just go ahead and write these two products down because you don't have to do anything with that. And then your metal, so our metal in this case is lead, so we're going to make a lead oxide. You would just check your charges and then make the formula. So again, here, check your charges. So basically when you're doing this, the most important thing is for you to check charges if you make an ionic compound. So check your charges when you make an ionic compound. Alright, so two other special decomp reactions. An alkali metal nitrate. So an alkali metal, that's group 1, 1A. Oh, let me write that down for you. That's group 1A. Will decompose into a metal nitrite an oxygen gas. So KNO3 is going to decompose into metallic nitrite, so you're going to check your charges here, and oxygen gas. Potassium's +1, nitrite is -1. All right, and then acids will decompose into a nonmetal oxide and water. So this is also just like one of the synthesis reactions, just in reverse. So if I have carbonic acid, it's going to make water, and then carbon dioxide. So I just took an oxygen away from this to make CO2. So let's say that I have H2SO4, and that decomposes. I'm going to make water, first of all. H2O like that. And then I'm going to take away an oxygen from the sulfate to make SO3. And that would be your decomp reaction. Okay, so single replacement, we watched a whole podcast on this. This is where one element replaces another in a compound. Okay, so we didn't really talk about, there's two of these that we need to talk about. Now, an active metal and water will form a metal hydroxide and hydrogen gas. Okay, so you might be able to see this without me telling you, because if you've been balancing your equations and you know that you can rewrite H2O. Oops. Okay. You can write H2O as HOH. Oops. I don't know why it's not letting me write. There it is. Okay. So H2O is also HOH. So if you're replacing the positive with the positive, you would replace sodium with hydrogen. So the sodium will bond with the hydroxide, become sodium hydroxide, and then the hydrogen would be displaced as a gas, H2, because it's a Brinkelhoff. But basically group 1 and group 2 will do this when you place it into water. So calcium will do the same thing. It'll make calcium hydroxide and hydrogen gas. All right, this is another one. I don't know if I need to say it, but I'm going to just go ahead and talk about it for a second. If you have a metal and you add it to an acid, the hydrogen will get displaced. It'll be a gas, H2, because it's a Brinkelhoff. And then the metal will replace the hydrogen, and in this case, it'll be magnesium chloride. All right, last one. All right, a displacement of a halogen. We didn't talk about this in the single replacement reaction notes, but it can be a nonmetal replacing another nonmetal in a single replacement reaction. And this happens with the halogens, but your halogens are not always found on your activity series, but all you need to do is look it up on the periodic table. So I'm going to show you that. It's the same way. So we're looking at the halogens, which are right here. The ones that are on the top are more active, so just like your activity series. So fluorine is the most active, then chlorine, bromine, iodine. So that means the free element needs to be higher for the reaction to happen. So in this case, we're looking at chlorine and potassium bromide. We are not comparing chlorine to potassium. We are comparing the nonmetal, which is chlorine, to bromine, which is the other nonmetal. And so if we look at the periodic table, right here, bromine is right here, chlorine is right here. So chlorine is higher, so the reaction will happen. Okay? So let's look at the next one, Br2 and KCl. We are not comparing bromine to potassium. We're comparing bromine to chlorine. So I'm going to check that. Bromine's right here. Chlorine's right here. Because chlorine is higher and it's already in the compound, no reaction. All right. That is it for special types of reactions, and I will see you in class.